All right, today we're going to dive into some multi-step equations. I can solve equations using the distributive property and combining like terms. So we want to isolate the variable. Here are your steps for multi-step equations. First, you always want to distribute. If you ever see a set of parentheses with a number outside, you're going to want to multiply that in. Then you combine your like terms on the same side of the equal sign. Now tomorrow we're going to have a step after this where it's going to be get the variables on the same side. Ooh, today we don't have that. Then we start undoing the operations by using the inverse. So we get rid of addition and subtraction, and then we get rid of multiplication and division. So this last part is like the two-step equations. So the only new stuff is we're going to distribute, and we're going to combine what we can on the same side of the equal sign. Here we go, example 1. There are no parentheses, there's nothing to distribute. So are there any like terms we can combine on the same side of the equal sign? And you're like, yeah, dude, we got 2x minus 9x. We could combine that. 2 minus 9 is negative 7, so negative 7x plus 17 equals negative 4. Now we have a two-step equation. I know with two-step equations, most of the time you're going to undo addition and subtraction first. I see plus 17. We could easily get rid of that by subtracting 17, because 17 minus 17 is 0. If you change something on the left side, you have to change it on the right to keep it balanced. These cancel out. We have negative 7x equals negative 4 minus 17 is negative 21. Negative 7x means negative 7 times x, so we're going to undo that with some division. X equals negative 21 divided by negative 7. Negative divided by negative is positive, so we have positive 3. Feel free to check it back in the original. 2 times 3 is 6. Minus 9 times 3 is 27. Plus 17 equals negative 4. If we go left to right here, 6 minus 27 is negative 21, plus 17 is, in fact, negative 4. Look at us. Now, we're not going to check every single answer just to make the videos shorter, but it is a good idea to do on your homework and on your tests and quizzes if you have that extra time. Example 2, we do have some distribution here. So we can multiply the 5 into each of these. Now, there's another way to solve this problem, but where we're going in the future, I wouldn't recommend solving it that way, because you could just divide by 5 on both sides, but in the future we're going to have more steps, so I wouldn't suggest that. So let's go ahead and distribute. 5 times x is 5x. 5 times negative 7 is negative 35. So we have 5x minus 35 equals 90. I see subtraction. Let's get rid of it. So we're going to add 35 to both sides of the equal sign here. We have 5x equals 90 plus 35 is 125. 5x means 5 times x, so we can divide both sides by 5. And 125 divided by 5 is 25. Yes! Look at us. Just cruising. I think we got one more to do together, and then I think you're going to try one. Fun. There it is. Now, we talked about this with the distributive property. That negative sign out in front, it's like there's an invisible negative 1 that we're going to distribute, but when you're distributing a negative 1, you just make everything inside its opposite. So this would be 6x, and then negative 1 times negative 3x is positive 3x. And negative 1 times 2, I'll write the 1 in there, is negative 2. So here's what we have. We've distributed. The next step says to combine like terms. On the left side, look at this. I could do 6x plus 3x. That would be 9x. Now, some of you might have initially thought like, oh, we can add 2 to both sides. And that's true. You could. But again, thinking about the future, these are like the most efficient ways to solve multi-step equations. So it's nice if you distribute, then you combine your like terms. But it would have still worked out. So now we're going to add the 2 to both sides. 9x equals 12. And then, yeah, 9 times x, so we'll divide by 9 on both sides. That will give you a decimal, but we're cooler than that. Let's go ahead and simplify this fraction. Now, what goes into 9 and 12? 3. 12 divided by 3 is 4. 9 divided by 3 is 3. So we have 4/3. If you do it in your calculator and it spits out a decimal, it'll be 1.33333. 1.3 repeating. So here's one I'd like you to try. Go ahead and pause, and I'm going to go over it and then check and see how you did. Combine our like terms. It'll be 1x plus 6 equals 21. We'll subtract the 6, and we get 15. Delightful. Just delightful. Solve each equation for y. When we're solving, we're isolating that variable. We're getting it to be the only thing on that side of the equal sign. So here we're wanting to just keep the y. So like we could add 7 to both sides. That would give us negative 2x plus 5y equals negative 12 plus 7 is negative 5. Now, we don't want this negative 2x here, so to cancel out a negative 2x, the opposite would be a positive 2x. So we're going to add 2x's to both sides. Now, 2x and negative 5 are unlike terms, so we're just going to leave them separate. 5y equals 2x minus 5. And we don't want 5y, we just want y. So we're going to divide every single thing by 5. You can't simplify the fraction 2/5. We're just going to leave it then. You could turn it into a decimal, 0.4, but we're not going to. We're going to leave it as 2/5 x, and then negative 5 divided by 5 is negative 1. This would be our final answer. Now this type of problem, we do this a lot once we get to graphing. We turn things into, this would be considered slope-intercept form. You get y by itself. So that is a nice skill to have in the future. I do have one for you to try here, but I will guide you a little bit on this. You could distribute the 2 now, but here's where I think it's actually nice to go ahead and cancel that out. When you distribute, you're multiplying. So here we could just divide both sides by 2, and that'll cancel out the 2 in front. So it would just be y plus 5 equals 2x. Now this would still work out if you distributed, that'd be fine. But now I could just get y by itself by subtracting the 5. And that would give us y equals 2x minus 5. That would be our final answer. All right, we got some story problems, some old word problems, and then we're out of here. So we're going to want to first assign some labels or variables. And then we're going to try to generate an equation from there and solve it. So you guys are obviously familiar with Sally and Sue, but they need to make 105 gift baskets for Christmas. I bet that's important to know. If Sally makes 20 per hour, all right, so there's Sally's stuff, 20 per hour, and Sue makes 15 per hour, how long will it take them to finish? So let's use the variable g for gift baskets. Now, if Sally is making 20 every hour, and I said, well, how many did she make in 3 hours? What would you do with the 20 and the 3? You would multiply them because she does 20 every single hour. So when you see per or each, it's a pretty good guess that it's going to be multiplication. So here could be Sally, 20 baskets per hour. Let's call her 20G. Sue is going to be 15 per hour, 15G. Now here's Sally, here's Sue. They're working together. So we're going to add the gift baskets together, and we want to see when it's going to be 105 gift baskets. So nothing to distribute. We could combine our like terms here. That would give us 35 gift baskets per hour equals 105. Now if we're like, all right, they can do 35 together every hour, how many hours is it going to take? So we could divide both sides by that 35. and our answer will be g equals 3. But we're human beings. If I said how long will it take them to finish and you said g equals 3, I would think you sound silly. 3 what? It's going to take them 3 hours to make all those gift baskets. Fun. All right, we're going to try another one. Now it says to do this on your own. Feel free to pause, give it a whirl, but I'm going to talk through it on this one. The swimming pool is twice as long as its width. If the perimeter of the pool is 144 feet, what are the dimensions of the pool? Now this is a sweet pool, man, but it's twice as long as it is wide. So if I was to call its width W, and this is 2 times as big as that, we could call this 2W. Now perimeter, you add up all 4 sides, or add up all the sides. Or there's a formula for rectangles. It's like 2 times the length plus width. I don't even think that's helpful in this case. Look, if this side is W, that means the opposite side would be W, right? Opposite sides of a rectangle are equal. If this is 2W, up here is 2W. So if we were to turn this into an equation, we'd be adding up all 4 of these sides. 2W plus W plus 2W plus W. When we add up all 4 of those sides, it says that the perimeter is 144 feet. There's our equation. Let's combine some like terms. 2W plus 1W is 3W, plus 2 more, we're at 5W, plus 1 more is 6W, equals 144. That's 6 times W, so we're going to go ahead and divide it. And we get x equals, let's see, 24, I believe. I wouldn't even say the answer is 24 feet because, oops, I made that an x. It's supposed to be a W. The question is asking, what are the dimensions of the pool? We only figured out that the width is 24 feet. So the width is 24 feet. That's part of the answer. But we also need the length. The length is twice as big as the width. So we have to do 2 times 24, which would be 48 feet. So the length is 48 feet. Guys, you did great. I'm glad you were having fun at home there. We did it.